Hello my dear students, this is Akash SD and welcome to the ASD physics classes. Hope so you are doing really great. So students, in this video we are going to learn about the electrostatic potential energy, okay? And this electrostatic potential energy is very similar to the gravitational potential energy whatever we have learned under the chapter of gravitation. But there is the one basic difference. What is the basic difference? The basic difference is that we know very well gravitational force is always attractive. That's why gravitational potential energy will be always negative. But if you talk about the electrostatic force, it can be attractive also whenever the charges are which nature? Opposite nature. And it can be repulsive also whenever the charges are same nature. That's why what I'm telling that here, as the GPE is always negative because of attractive force. But EPE can be positive also and can be negative also. In which situation it will be positive? Whenever electrostatic forces are repulsive, that time EPE will be positive. And whenever this electrostatic forces are attractive, that time EPE will be negative. That's why at the end I want to tell you GPE will be always negative. But EPE can be positive also and can be negative also. Okay, so after knowing all these basics, we are going to learn everything in a detail. Okay, so let's start the video and let's learn all these basic things in a very detailed manner. Okay students, so let's see here please. So we can see very well electrostatic potential energy. So see here, EPE of a system, maybe 2 particles, 3 particles, is defined as the amount of work done by external forces against the electrostatic forces to make that system without changing the kinetic energy. We have to make sure that the kinetic energy should not change. In that situation, whatever work will be done by the external force, what it will do? It will change the potential energy. So this concept should be always valid whenever we are studying about the electrostatic potential energy. Okay, so what are the important points are there? First one, let's see. EPE of a system of particles is defined only for conservative fields. What are the conservative fields are there? We know very well in case of conservative forces or conservative field, what will happen? Work done does not depends upon the path. And second thing, work done in a round trip will be always zero. These two things we have to remember that. And remember that this potential energy concept is only applicable for the conservative forces. What are the conservative forces are there in our syllabus, like electrostatic force, in 11th gravitational force, spring force and all these things. But here as of now, we have to remember that this electrostatic force is the which force? Conservative force. Conservative force. Okay, so only this potential energy concept will be applicable. One more concept is there, when electric field is coming from the change of magnetic field, that is the non-conservative. There this will not be applicable. Okay, so as of now remember that here conservative force if electrostatic force or field is coming from static charges, not from the change of magnetic field. Okay, great. Second one, let's see please. EPE of an isolated charge particle is always zero. Okay, because it is defined only for a pair of charge particles. As of now, please remember that. Later at the end of the video, we will understand it very well. So students, please remember that here, this basic concept. Okay, now after that, we are going to move for the some other important points. Third one, as I have told you in the starting of the video, EPE will be positive if resultant electrostatic forces acting among charged particles are repulsive. Okay. Fourth one, EPE will be negative if resultant electrostatic forces acting among charged particles is what? Attractive. Okay, so please make sure that when EPE is positive, repulsive force, EP is negative, attractive force. Okay, now relation between EPE and electric potential. EPE means electrostatic potential energy and EP means electric potential here. So say here, due to some charge configuration here, electric field in this direction. Okay, now what we are going to do? We are going to move one charge particle from point A to point B. Now you think very well on this charge particle, what will happen that here? You know very well the positive charge particle always experiences electrostatic force in the direction of the field. Okay, but we want to move the charge particle from point A to point B against the electrostatic force. So what we have to do here? Here we have to apply one external force here. What we have to do? We have to apply one external force. And remember that if in case the kinetic energy is not changing, delta K is 0. So in this situation, what will happen that here? This F external will be equal to minus of Fe. in a vector form, because both in which direction? Opposite direction here. Okay, now what I am going to tell you, so see here please, potential difference between point B and A. B is the final point, A is the initial point. So potential difference between point A and B is defined as work done by external force to move the charged particle from where to where? A to B. And which kind of charged particle? Unit charge particle. That's why we are dividing with the Q. And as I have told you, if in case there is no change in kinetic energy, this delta K is 0. So what will happen? That from work energy theorem, one more point we can write here, work done by the external force plus work done by the electrostatic force will be how much? 0 here. Work done by all the forces will be 0. So what we can tell here, W external will become what here? Minus of WE, and here A to B by Q here. Okay. But what we need here? We need only this thing here. If I write here, see, we need this. Work done by the external force to move from A to B is defined as Q into VB minus VA. Okay, or we can tell here work done by the external force will be what here? Q into VB minus VA is what here? Delta V. And one more thing. If in case kinetic energy is not changing, okay, kinetic energy is not changing, so work done will change what? Work done will change the potential energy. That means we can write here work done by the external force is equal to delta U equal to Q into delta V. This is the relation between electrostatic potential energy and electric potential. Very, very important relation is there. Please remember that here. Okay, so this complete concept is based upon kinetic energy is not changing and work done by the external force is equal to change in potential energy. Okay, great. Now students, let's see. We are going to see the cases. First case is what? Case 1. Case 1 is EPE of a system of two charge particles. So what we want to make? We want to make the system of two charge particles. So let's say this very well. One charge particle Q1 is infinity, and let's take somewhere here, and the charge particle Q2 is also infinity. Okay, both the charge particles were at the infinity. Okay, so what I am going to do here, first this Q1 charge particle I want to take it here. Okay, I have taken Q1 here at this point. Okay, and let's take this point I have taken A. So what will happen that here, this work done by external force will be what? Work done by the external force to take the charge particle what? Q1 from where to where? From infinity to point A. Okay, work done by the external force by charge particle Q1 we are taking where to where? Infinity to point A. Okay, plus after that what will happen that here, this Q2 also I will take where? At point B here. Okay, and now Q2 will come. So plus work done by the external force, okay, to take the charge particle Q2 from where to where? From where to where? From infinity to point B. Okay, first infinity to A, then infinity to B. So students, please remember that here, as the kinetic energy is not changing, so what will happen that here, work done by the external force is equal to change in potential energy. Now please make sure that when the first charge particle Q1 is coming from infinity to A, before that is there any charge particle is present? No charge particle is present. Okay, so there will not be any opposition. Okay, so when the first charge particle will come from infinity to point A, as there is no electric field before in the space, so what will happen that here, this work done will be 0. Okay, plus now what will happen that here, this charge particle Q2 will come in the electric field of charge particle Q1. In this situation what will happen that here, work will be done by the external force to take the charge particle from infinity to point B in the electric field of where? In the electric field of Q1. So here what we can write here, we can write here this Q2 into potential at point B due to A here. Okay, so now what will happen that here, this delta U we can write here, U potential energy of the system minus U infinity is equal to 0 plus Q2, and you know what is the potential formula? We can write here 1 by 4 pi epsilon naught into potential at B due to A. So Q1 by, let's take this distance, how much here? R12. Okay, and please remember that here, what will happen that here, we are considering at infinity potential energy of all the charge particles, how much? 0. So hence we are getting potential energy of the two particle system 1 by 4 pi epsilon naught into Q1 Q2 by R12. Okay, for two particle system this is the potential energy. Please make sure that very well. Okay, great. Now students, next one in the same way for a system of 3 charge particles. Okay, so what I am going to do here, again let's take here, this Q1 is there at infinity, somewhere Q2 is there at infinity, and somewhere Q3 is there, okay, at infinity. So what I am going to do here, first I am going to take here this Q1 here. Now Q1 came here at point A. Now, so here what will happen that, see, work done by the external force. Which charge particle we are taking? We are taking Q1. From where to where? We are taking from infinity to A. So what do you think that here, how much work will be done? The work done will be 0 because there is no charge present in the starting. First charge is Q1 is coming. So no previous electric field. That's why the work done will be how much here? 0. Second one, what will happen that here? When the charge particle Q2 will come here. No? When the charge particle Q2 will come here, at which point? At point B. Okay, so in this situation, what will happen that here? Work done by the external force to take the charge particle, what? Q2. From where to where? From infinity to B. So what will happen that in this situation? Before that, which charge particle is present? Q1. So Q1, and here what we can write here? Potential at point B due to A. Because charge Q2 is coming in the electric field of Q1. Okay, similarly, after that, next one, if we'll go here, see, plus. Now what will happen that this third charge particle will come here. This third charge particle will come here, no? And what is there? Point C. So now this third charge particle is coming into the electric field of Q1 and Q2. That means what we can write here? Work done by the external force to take the charge particle Q3. Okay, from where to where? From infinity to C. So plus, what is coming? This Q3 is coming. No? This Q3 came here. So plus Q3, and it is coming in the electric field of 2 charge particles, that means Q1 and Q2. So we can write here potential at point C due to A plus potential at point C due to B. Okay, and this one will become what here? Delta U. So now I am going to put all these things. So this will become here U minus U infinity is equal to 0 as it is. Q1 and C. Potential at point B due to A. Let's take this distance, how much here? R12. So I can write here what? Let me write here the K. Which one is coming here? Q2 is coming, na? So this is Q2 actually, na? Q2. And here K, Q1 by R12 plus Q3, no? Q3. And here what will happen? We have to write potential due to charge Q1 and due to charge Q2 also. So let's take this distance, how much here? R23, and distance how much here? R31. So due to Q1, how much potential will be there? K into Q1 by this distance R31 plus, see, K into Q2. Now Q2 is here and this distance R23. So what will happen that students? Again, I am telling that here this U infinity will be how much here? 0. Okay, that means we can write here this U equal to K, and here we can write here, see, K Q1 Q2 by R12 plus this one will become Q1 Q3, no? Q1 Q3 by R31 plus, let me change the color here, plus Q2 Q3 by R23. Okay, so like that, what will happen that here when fourth charge particle will come, it will come into the electric field of 3 charge particles. Okay, so no need to do all these things again and again. What we have to see, we have to just see the number of pairs. Okay, so if you see this system here, how many pairs are there? Here you can see here 3 pairs are there, like Q1 Q2 Q2 Q3 Q3 Q1. Okay, so please you remember that here number of pairs for n charge particles will be how much here? N minus 1 by 2. Now please make sure this one here. Now, so if we have to do for the next one, this one, 4 charge particles. So again, no need to do all these things. Again, what I will do here, directly I will write here, see, directly here, please see. This is Q1, now this is Q2, this is Q3, and this is how much here? Q4. And let me write here the distances. What will be the distances here? Yes, guess, R12, R23, and here R34, and here R41. Can you see here how many terms will be there in a EPE? So see here, please. Number of terms means number of pairs. Number of terms means what? Number of pairs. And what is the formula? As I have told you, n minus 1 by 2. Number of charge particles, how much? 4. Okay, so this is 4. 4 minus 1, 3 by 2. So how many pairs will come? 6 pairs will come. How many pairs will come, students? 6 pairs will come. Okay, so I will write here the potential energy U equal to K. K means 1 by 4 pi epsilon naught. Okay, So let me write here the pairs first sidewise, 2, 3, 4. So K, let me write here, Q1, Q2 by R12 plus next one, what will become here? Q2, Q3 by R23. Next one, Q3, Q4 by R34 plus next one, this one, Q1, no? Q4 by R14 or 41, 4 pairs. But total how many pairs are there? 6 pairs. Where are the two other pairs? Diagonal pairs here. This diagonal pairs. Okay, so let me write here. This distance will be what? This distance will be R24. Okay, so this will be K, Q2, Q4 by R24, and one more pair is there. This one here. See, this one diagonal wise here. This one here, 1 and 3. So we can write here R13. So plus K. K already is there. So K, Q1, Q3 by R13. Okay. So in this way, we have to write the potential energy for 2 particles, 3 particles, 4 particles, 5 particles, 6 particles, whatever. Okay, great. So here we have some special cases are there. Sometimes they will ask the special cases. See the special cases. Special cases of a system of 3 and 4 charge particles. So here what I have taken here, let's take here I have taken Q. Here also I have taken Q. Here also I have taken Q here. Okay. And this distance is how much here? R, R, R. Now equilateral triangle. So here what is the potential energy? Directly we can write here 1 by 4 pi epsilon naught. How many pairs? Anyhow 3 pairs are there. So first one we will write for the one pair, this one, this Q, Q. So Q square by R. So this is also Q square by R. This is also Q square by R. This is also Q square by R. So we will just multiply with the 3. So it will come this answer. Okay, great. Now after that, if I talk about for the second one. Now 4 charge particle. Let's take here Q. Let's take here Q. Here Q. And let's take here how much there. Let's take for example, I have taken minus Q. Because minus also possible. So in this situation, now we have to be very careful. U equal to K. See this distance. Let me change the color here. Let's take this is R, 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 R. If all are positive means we can write very easily. But if one is negative, then what we have to write here? First I will write for this one here. What will become here? Q square by, this is Q square by R. This is also Q square by R. Plus this one, what will happen? Q into minus Q. No, minus and very important, by R. Plus this one here again, minus Q into Q by R. Plus now the diagonal wise. Diagonal is what will happen that here. See this one here. What this will become a Q into Q. That means Q square by R root 2. Plus now see here Q and here minus Q. This diagonal here. So what this will become here? Q minus Q by R root 2. Okay, great. So see here very well. And as I have told you very well, at the end of the video, I will tell you one very important concept that I told in the starting of the video. What is that? See, EPE of an isolated charge particle is how much? 0. Why? Because there is no work done by external force against any electrostatic force to take that particle from infinity to make the system, as we have seen in the derivation and all that. Okay students, so I hope so all these things are very clear to you. In next videos and all that, we will solve multiple questions and all that. Okay students, keep studying.